Okay, yeah, I will record this and upload later. Yeah, so hopefully you okay, my voice is clear, thank you. All right, okay, let's continue. Okay, yeah, so that is how lah. Yeah, based on, you know, this ratio is a ratio. It's a ratio of change of resistivity due to change of temperature at to the resistivity at 20 degrees Celsius. So what it means here is this R naught is actually resistivity resistivity at what, at T naught, which is equal to 20 degrees Celsius. Okay, so the whole thing here, the whole thing at the top, yeah, below is called the resistivity. The whole thing at the top is a ratio lah. Is a ratio. Ratio of change. Okay, ratio of change. So I can say this. I can say alpha is actually like, you know, 20% change of 20% change of resistivity for a change of 1 degree Celsius. That means if the temperature increased 1 degree Celsius, the resistivity has changed 20%. Has increased 20%. That is what it means lah. Okay, 20% change. It's a ratio lah. It's a ratio of change when compare the change to the resistivity at 20 degrees Celsius. This is what it means by the statement below here. Ratio of change of resistivity due to a change of temperature comparing to the resistivity at 20 degrees Celsius. This is what I mean by the R naught here. Yeah, R naught is the initial resistivity when, you know, the initial temperature is 20 degrees Celsius or 0 degrees Celsius. Actually, got two temperature lah. Yeah, I will explain more about this. But for there is the, you know, that is the, this one also depend on material lah. Different material, yeah, different. I hope that it can take down notes somewhere, maybe on a paper or what. Yeah, so different material, different, you know, different resistivity. Okay, different, all based on material lah. All based on material lah. Okay. All right. So the thing I want you to focus here also is the unit. The unit for resistivity is what? So based on this formula, from this formula, you can actually just find the, you know, yeah, just I copy again the formula over here. Okay. So what's the formula? What's the unit for alpha? Alpha, resistivity we know is ohm meter, right? Not? And then below here got ohm meter, and then this temperature is either degree Celsius or Kelvin. Because you can either degree Celsius or Kelvin, yeah. Because why? Because this is change of temperature. It's not just refer to temperature. It's refer to change of temperature. So change of temperature, you can either two unit. You can either degree Celsius or Kelvin. Understand? So you cancel, you know, the unit. So that's why we alpha is per degree Celsius. No, sorry, what, I'm wrong really. That's why alpha is per degree Celsius or per Kelvin. Understand, class? So that's the unit for the unit for alpha. Okay. Now the following things is understand, class?
Yes.
Okay, thank you.
Yes, sir.
Yeah. All right. So, okay, when you substitute, you know, this resistance final equal to initial resistance, and then you substitute, I mean, alpha R naught delta T, you substitute into here, and then you derive, in the end, you get these two formula lah. You get this formula and also this formula. I don't think I need to repeat this because I have shown you before. Yeah, it's just same like the thermal expansion part, yeah, like semester 1. So you get these two formula. Now I want to proceed to explain about this T naught, yeah, T naught and R naught. Okay, let me let I just show it over here. Right, more comfortable with my own writing actually. R equal to R naught 1 plus alpha. We have T minus T naught, and then we can also use this formula 1 plus alpha T minus T naught. Okay, class. So the thing is, if you can see, T naught has a specific temperature. It must be either 20 degrees Celsius or 0 degree Celsius. And the resistance R naught is the resistance at this temperature. Understand? It has a specific temperature. So normally we say this T naught is actually, we call it the reference temperature. It's a reference temperature. It must be either 20 degrees Celsius or 0 degrees Celsius, or sometime we just use a room temperature. We can also sometimes use 30 degrees Celsius. Yeah, sometimes lah. T naught must be either this value. It must be room temperature or 0 degrees Celsius. Yeah, and R naught is the resistance at T naught. Yeah, it is the resistance at T naught. R naught is the resistance at T naught. That means at this temperature lah. Yeah, at hold on a second. My kids are shouting over there. Need to tell them something. Okay, so this if T naught is 20 degrees Celsius, that means R naught must be at 20 degrees Celsius lah, yeah, or 0 degrees Celsius. So if you see the question, he gives this temperature 20 degrees Celsius or 0 degrees Celsius. Remember to put them at T naught, not at T. Yeah, understand? So this one also the same lah. This over here, this T naught also the same. Must be either 20 degrees Celsius or 0 degrees Celsius. Okay, so I think that's about it. Yeah, that's about it. So now let us solve some questions. All right. Okay. Let me just put this on hold. Okay.